Okay, so imagine this for a moment. You're looking at reality, and everything feels stable, solid, predictable, real. Objects exist where you see them, time moves forward, cause leads to effect. But now imagine this. What if that's not what's actually happening? What if reality, at its deepest level, doesn't behave the way you think it does? What if the more we investigate it, the less familiar it becomes? Because over the past century, physics hasn't just discovered new answers, it's uncovered questions that challenge reality itself. Let's begin. Number 10. The double-slit experiment. In 1801, Thomas Young performed one of the simplest experiments ever designed. Light, two slits, a screen. If light were made of particles, you'd expect two bright lines. But instead, an interference pattern appeared, a pattern that only waves can produce. That alone was strange, but it got worse. When scientists repeated the experiment using single particles, individual electrons fired one at a time, the same pattern emerged. Each particle somehow interfering with itself, as if it passed through both slits simultaneously. And then something even stranger happened. The moment you try to observe which slit it goes through, the pattern disappears. The particle behaves normally, as if the act of observation changes the outcome. Physicists like Niels Bohr and Werner Heisenberg built entire interpretations around this. But even today, no one agrees on what it really means. Because whatever is happening in that experiment doesn't fit our idea of reality. Number 9. The mathematical universe. In 2007, MIT cosmologist Max Tegmark asked a simple question. Why does mathematics describe reality so perfectly? Not approximately, precisely. Equations written on paper predict the behavior of the universe with extreme accuracy. From planetary motion to quantum fields, math doesn't just describe reality, it matches it. Tegmark's conclusion was radical. The universe isn't described by mathematics, it is mathematics. If that's true, then any mathematical structure that is consistent exists physically somewhere. Not metaphorically, literally. An infinite number of realities, each defined by different equations, different rules, different physics, different versions of existence itself. And we just happen to exist in one where the math allows us to exist at all. Number 8. The many worlds interpretation. In 1957, Hugh Everett III proposed something most physicists initially rejected. What if quantum events never collapse? What if every possible outcome actually happens? Every time a particle could go left or right, the universe splits. One version where it goes left, another where it goes right. Nothing is lost. Everything happens. This became known as the many worlds interpretation. And over time, even physicists like Stephen Hawking and David Deutsch took it seriously. If it's true, then right now there are countless versions of you, making different choices, living different outcomes, existing in parallel, but forever separated. Not science fiction, a real interpretation of quantum mechanics. Number 7. The cold spot in the universe. In 2004, data from NASA revealed something unexpected, a massive region of space, colder than it should be, known as the CMB cold spot. It spans about 1.8 billion light years. Too large, too cold, too unusual. It was later confirmed by the Planck satellite, which means it's real. Some scientists suggest it could be a massive void. Others propose something far more extreme, a collision with another universe, a point where our universe may have interacted with something beyond it. There's no confirmed explanation, just a massive anomaly sitting in the sky. Number 6. the fine-tuning problem. The universe works, but it works with extreme precision. If certain constants were even slightly different, gravity, dark energy, nuclear forces, nothing would exist. No stars, no galaxies, no life. Physicist Martin Rees highlighted this in his work. The margin for error is almost zero. So why does it work? There are only a few possibilities. It's coincidence, it's necessity, or there are countless universes, and we exist in one that allows us to exist at all. None of these explanations are fully satisfying, but the question remains, why is reality so precisely balanced? Number 5. The simulation hypothesis. In 2003, philosopher Nick Bostrom proposed a disturbing idea. If advanced civilizations can simulate reality, then statistically, it's more likely we're inside the simulation than in the original base reality. And then physics added something strange. At the smallest scale, the Planck length, space and time appear discrete, almost like pixels. And in some advanced physics equations, researchers have even found structures similar to error-correcting codes, the kind used in computers. This doesn't prove we're in a simulation, but it raises a question. Why does reality sometimes behave like information? Number 4. Eternal inflation. In 1980, Alan Guth proposed cosmic inflation, a rapid expansion right after the Big Bang. Then, in 1983, André Linde extended the idea. What if inflation never completely stopped? What if it continues, creating new universes constantly? Each one a separate bubble, each with its own laws, its own constants, its own version of reality. If this is true, then our universe isn't the universe. It's just one region in an endless process of creation. Number 3. The black hole information paradox. In 1974, Stephen Hawking discovered that black holes emit radiation, which means they can evaporate. But this creates a problem. In quantum mechanics, information cannot be destroyed. But if a black hole disappears, what happens to everything that fell into it? Physicists like Leonard Susskind proposed a solution, the holographic principle, the idea that all the information inside a volume of space is encoded on its surface, which leads to a deeper implication. Our 3D reality might be a projection of something more fundamental. Number 2. Eternal immortality. In 1987, ideas later explored by Max Tegmark suggested something deeply unsettling. If many worlds is true, then from your perspective, you never experience non-existence, because in every scenario where you don't survive, there's no you to observe it. Your consciousness only continues in branches where you survive, no matter how unlikely, which leads to a strange possibility. From your own perspective, you might always continue, not because you're immortal, but because you can only exist in the outcomes where you do. Number 1. The Boltzmann brain problem. In 1896, Ludwig Boltzmann explored the idea of randomness in the universe. Given enough time, even extremely unlikely events can happen, including something like this: a fully formed brain appearing out of random fluctuations, with memories, thoughts, a sense of identity, believing it has lived a life, but none of it actually happened. In an infinite universe, these Boltzmann brains could outnumber real observers, which leads to a disturbing conclusion. Statistically, it may be more likely that you are one of them than a being with a real past. There's no clear resolution, just a question that lingers. How do you know your memories are real? And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.